Yeah, that was a really interesting talk about various aspects of the blockchain security. So now we have Pablo, uh, who would be guiding through more steps about the Web3 security. So we will be just back in a minute. Stay tuned. Yeah, hey Pablo,
Hello, how are you?
am I visible and clearly
Oh,
audible?
yeah, I'm fine, thanks. It was a busy morning trying to find a good spot to have a good connection and to connect properly. But finally, uh, I've got the solution. So I'm ready, and when you want, you can enter me.
Yeah, that's great. I mean, so I think we are good to start now.
Okay.
Yeah, great. So, can you just give us a small introduction about yourself? Like, how do you got into the like Web3 security and all the aspects, and how do you just build across interest across fields?
Okay. Perfect.
Uh,
So
yeah, yeah. So, would you just give a small introduction about yourself, Pablo?
hello. Okay, we are online. Thank you very much for this invitation. I hope you are doing very well. I'm really pleased about that. My name is Pablo López. I'm from the northwest of Spain, in a region called Galicia, just too close to Portugal. And I am involved in all this crazy technology that we used to call blockchain or DLT or whatever. I started it in 2014 when I was in Central America living, and I started to watch, and I started to feel how some people was using technology just to transfer them value through a figure called a cryptocurrency. In fact, it was Bitcoin. And my background was a guy who was focused on marketing and technology. I'm mainly more worried about how was the people and the person has influence about the technology and how the technology could help people to improve their quality of lives and the relationships, and how this technology could empower people, just throwing out the middlemans and mainly the central institutions. So it allowed me to stay in a first period of my life working with big multinationals inside in home, uh, in the areas of IT and security and privacy. And after that, I decided to run my way. And when I get this deep contact with this technology, I decided to follow my way. Sure that in 2014, when I was at the Bitcoin conference and I saw the Vitalik's introduction to Ethereum, it was a fact that realize us what we can do with technology, and how the programmable money with the smart contract figure or the ERC20 tokens in a first step. Now the NFTs is in high, but there are tokens as well. How this kind of software could automate and execute with total transparency and with confidence a lot of actions. So in the following years, I started to understand and to be part of different projects. And okay, it was in the 2017, I think, when the ICO fever and so on, and they started to write a lot of white papers. I started to get involved and to get very involved in how the security of this software security in the meaning of risk, how the security of this software or of these pieces of software called smart contracts were built. No? And I realized that even when, sorry, and I started to realize that even when we were talking about decentralization all the time, most of the configuration of these softwares was not really decentralized at all because of matter of scalability, because of matter of resources, because of matter of data availability. So I started to realize how it was being a problem on how these smart contracts were configured, and mainly not only on the on-chain analysis, mainly on the off-chain analysis, because the smart contract needs real data. I mean, needs data from we can say the real life, needs physical data provided by IoT devices or provided by pieces of software or data feeds or whatever, needs this data, and how we were protecting these smart contracts so much. It was based on cryptography, in fact, but we don't realize the problems of introducing the data on or of how are introducing this data. And that is when I decided to put the focus on it. I started to study about that, to talk with so many projects, to talk with so many people about how these configurations were being made. And the previous colleagues were talking to about the oracles and how the oracles be confident and so on. So I decided to realize on how we can fix or we can help to solve these kind of problems. And therefore, I started to make these contracts, to study this code, and started to, from a point of view of a blockchain solutions architect, how this configuration were misunderstood and how this configuration could improve. And it was when I started to play with different roles. About me, I can tell you that I have three, we can say three personalities. I have the developer personality, where I am focused on cybersecurity in blockchain, also in the smart contract audits, also in the layer of the forensics. I have the business hat because I love making the business development of projects and how to scale up and how to grow them. And then the investors too, because I have the chance to meet people who want to invest in this kind of projects. That was the main idea of my blockchain venture builder called CreatiBlock, where I put in contact startups, corporations, and investors to develop projects. What kind of projects? Well, I love so much cryptocurrencies, of course. I love privacy, of course. But I am more focused on, I can say, real solutions like biotechnology, like health data, and so on. So with this blockchain venture builder, I could develop several projects, and one of them is called Equantum, and Equantum is an own business with two colleagues, with Fabian and Walter. One now is in Israel, and the other one is in Panama. And we develop a script to make security on the cloud configurations of our databases or our data feeds, and mainly when these data feeds are the ones who feed the oracles of the smart contract. No? And here's when the main topic of this conversation is about that. Okay, it's about that how this cloud configuration or this cloud misconfigurations can put in risk, in a very high risk, our projects. And these first 2 months of the year are being really, really, really crazy about how smart contracts are being exploited, or maybe not smart contracts, but the database that feeds the oracles of the smart contracts are being exploited continuously, and well, with the results that we all know. So, putting the focus on that, I will be very pleased if you can make any question or any suggestion or any reflection about that. I would like to start to share you just three slides. Unable to spare. Okay. If I want to, I think that if I need to share, I need some privilege on the session. Okay, no matter at all, I can explain that to you.
Uh,
And
you can just try sharing your screen. You have full access.
okay, I think that no, don't worry about that. I was trying to just to share a slide. Don't worry about that. I can manage it. Okay. What I wanted to tell you is about this risk of the smart contracts, and from the category of the risk, we can find the origin of this problem. No, we can have operational risk. I mean, the risk that requires the authorization or the features that are exploited when the token network the governance is insufficient or flawed. Mainly there are on-chain problems, on-chain risk. We have implementing risk that are mistakes that we can make in the smart contract, and that makes that the behavior of the smart contract can be corrupted, or can be working not as I was thinking to. And then there are also this design risk that it was required when we designed the architecture of the project. We should realize that most of the project that we are watching now on the ecosystem, and we can say the DeFi projects and so on, most of them, maybe 90% of them, are not original. I mean, they are forks. In 2019, when we were living the DeFi summer, and when we started to show what DeFi can do with the smart contracts, we started to watch how I think it was Uniswap starting to put the solutions on the real thing. And then after that, we started to show so many decks, so many decentralized exchanges that was really forks of Uniswap. And in fact, if you go to the GitHub of Uniswap, I think that you can see more than 1,500 or 2,000 forks of the same code. That means that when you in the code and in the smart contract of the oracle that you use to feed or to input to give the data to the smart contract, if you just make a fork that is a copy and paste, you miss a lot of things, a lot of links, about where are you catching up the data. So that means that those links or those connections are not secured. So you feed the smart contract with data that it is not secured. Of course, that oracles, in fact, Chainlink, I love Chainlink. The oracles with the smart contract is well designed, use different tools and use different aspects to determine how to dismiss data that could be dangerous or that could be not trustable. But most of this data could have the appearance of good data, but they are not. So if we are just making this copy and paste, and we don't provide good data to the smart contract, we all know what happens. So that's why it is very important, of course, from an architect point of view, of the design of the project, on how the project is started, how the project will solve a problem, and what is the main data that we have. And why this is so important for me, and I want to emphasize this, because when we write the smart contracts, now, okay, all people say, no, a smart contract, it cannot be stopped when time is running, and this is false. Okay, we can pause, we can introduce in the code the pause function, and we can introduce the situations where the smart contract can be paused. And one of the reasons that we use the pause function is that, no? is the reason that if the smart contract introduce data that doesn't, I don't know if it fixed the right word, but when you introduce data that it is not the proper data, the smart contract can be paused by the owner, or can be paused by the code. And if you introduce with a purpose this corrupted data, you can pause the smart contract. And if you can pause the smart contract, you can make an intervention on it, and that is when you can make the exploit. So this operational risk that I mentioned before, it's we have, or we need to take it in account, because there are like 10, I think that it could be 10 aspects of this operational risk, like this super user, no? This owner of the smart contract who introduced this pause function, and how this super user can be supplanted or can be corrupted. So the smart contract implement function allow this privileged role to unilaterally or arbitrarily alter the functionality of the asset. So here is a point of failure, as well as the blacklisting or barring functions in the smart contract. Okay, this implementation function that allows a privileged role to prohibit a specific address from exerting an essential functionality. And why this is important for me? Because if you have this kind of functions in your smart contract that are connecting, that are capturing, that are collecting the data from the cloud services mainly, if you introduce this corrupted data, you can pause. You can pause the smart contract. And when you can pause the smart contract, there is a vulnerability, of course. Another operational risk would be the logic of the contract, or the asset configuration, no? That can be arbitrarily changed, as well as the cloud services. When I talked to you before about my company and how we started to make audits from the cloud environments in the smart contracts and the cloud environments of the data, we really realized that maybe 70% of the configurations of the cloud data, and we all know that most of the smart contract that we are watching and the Oracle feeds comes from AWS, from Micro, from whatever, and they are coming from data cloud that are not, that doesn't have a good configuration, and this is we can say that this is the basis of the cybersecurity. I mean, this is the basis of the security, in fact, on how do you configure it. Because even when you use this kind of services, you have a contract about what is your responsibility and what is the responsibility of the cloud provider. So if you don't make it properly, then you can put your smart contract in risk. So it is totally an off-chain risk that you can manage, but you don't do it properly. So this is the reason where you can find operational risk like the self-destruct functions. The smart contract, when it implements this function, allows a privileged role to remove tokens or remove tokens from the blockchain and burn or destroy all tokens and duplicate them or whatever. And these kind of actions that are occurring in the on-chain part could be corrupted from the off-chain part. And this is why I am obsessed about that, about how the cloud configuration. Of course, there is a solution. The solution is full decentralized, IPFS or another solutions about how to decentralize this storage data that you need to put in your smart contract. But we realize that from where we take the data from our smart contracts, this is not from a decentralized structure. I mean, a simple smart contract about and if this and that, if the weather is sunny, then that close the window. To know if it is sunny or not, you use your Oracle, and your Oracle is provided by, of course, you can use IoT, sensor, whatever, but you use also the National Institute of Weather or Temperature or whatever that are providing this data through a cloud configuration. Okay, so this is why it is a big problem for all of us who are involved in smart contract development, and we are involved in this security, about from where we are taking the data, and if these data are coming from a cloud service, to check if this cloud service is well configured, if it has risk, who is putting the data, how are they putting the data there, and we need to make this kind of check-ins. Okay, for instance, another operational risk are the minting functions. When the smart contract implements a function that allowed a privileged role to increase circulation or not, and we are at the same place at the same time. I mean, if your smart contract has the function that if there is not enough liquidity, or if a big part or a percentage of the tokens are accumulated by a single one, you can automatically generate new tokens or generate new supplies in order to make this arbitrary account or the balance of the arbitrary account to make it properly. We are at the same time. It's how do we know that someone is accumulating? You can find this info on chain, but you can take this info also off chain from a cloud service. Mainly the exchanges that we are used to watch every day, and the hacks that we are watching every day at the exchanges are in this cloud part. I mean, in 2 years ago in Spain, there was a big hack. Yeah, it was a big hack. It was 6 million euros of hack from the wallets of an exchange. And the vulnerability, it was off-chain. I mean, the centralized exchange has a database stored in the cloud with all the users, and the wallet linked to these users. And then this info is the info that feeds the different operations that you can do in the centralized exchange. So if you can corrupt this database, if you can corrupt, and you can enter in this database stored in the cloud, you will have the wallets, and you will have the addresses of the people who are storing the biggest accounts or more accounts. So you just need to have this address. You just need to use the code to access to this wallet that is in the database, and you can make this supplantation of identity. So this is a big problem that we have, and we are, in my opinion, we are not being really confident about how the risk of the cloud services are inside of our projects. We talked about this operational risk in this cloud configuration. We can talk also the implementation risk. Implementation risk, like rolling a non-crypto and a unique contract logic. So this implementing function that allow the holder of a privileged role to unilaterally and arbitrarily alter the functionality of the assets. We are at the same situation. We are giving this privileged role because it's the owner of the code. We are giving this priority, but then we feed this priority with data from a cloud. And as I am talking to you these last minutes, this data can be corrupted. We can make an unauthorized transfer. We can make incorrect signature implementations, and we can make this kind of risk often and more often than that we think. Just to finish with this kind of risk, we can have also this for me the bigger one, the design. Okay, the design risk. The design risk mainly are two kinds of risk. One is the untrusted control flow. The untrusted control flow show us that the smart contract invokes functions on different smart contracts in order to trigger a functionality not defined within the contract itself. That means that when you have in a project, you know, most of the times you don't have only one smart contract, you have several smart contracts. And if this, you have to interactuate with these several smart contracts, you have to fix too if these other smart contracts, how they are catching the data and how they are managing the data, and if this data were took also from the cloud. Because maybe you can say, okay, I am not using data cloud, I am using IPFS or whatever, but you are interacting with another smart contract inside of your same project, and these other smart contracts are the ones who are interacting with cloud data. So it puts us in a matter of design, and that we have to be very, very, very aware of which smart contracts we are interacting with them and how we are managing them. In fact, these design operational risk are the ones that, in my opinion, are putting us in the most complicated situation. I mean, this untrusted control flow or the dependence of the transaction. For instance, if you provide this data and this data allows asynchronous transaction processing that it can be exploited for profit or protocol through this mempool where we're recording all the transactions. All that means that if you don't have this ability to design and to make this architecture aware of these cloud data introductions, it is not easy that in the mempool of the project or in the mempool of the net of the blockchain, you can introduce these transactions, and once the transaction is fixed in the block, it's done. It's done. And if we are using Bitcoin, each 10 minutes, we will have the block. But if we are using another blockchains, it's a matter of seconds. It's a matter of seconds. So this is why this design risk must be one of my opinion, one of the priorities when we are designing the structure of the architecture of the smart contract, in order to determine if this data is provided by a cloud service or it's provided from where. From a more technical point of view, we can follow the code and we can have this smart contract audit and try to find, it is like a tip, we try to find if in the smart contract includes the pause function to watch out from which reasons or how this pause action could be activated, if it could be activated only by hand, by the owner of the code, and how the owner of the code made the decision to pause it, in which situation. Many of the times you can find that there is another smart contract who makes this decision, but you can find in the code and in the docs of the code, you must find if you are taking the data from these cloud services, because what I'm telling you is about my opinion and my experience on how the smart contracts that I have to interact to it are being configured, and how in this crazy race of developing this technology, how we are using these cloud services, and even most of the time we forget that we started this technology and we started this revolution because a lack of security, not because of a lack of expenses, gas, or scalability of quantity of data or whatever. So if we go to the principles of the Bitcoin white paper and what happened before, and when Xavo determined the smart contract function, we must realize that the security should be the priority. Security should be the priority. And most of the time we are forgetting that. We are forgetting that, of course. So just to go to the end of this little explanation, just to show you how in a code of a smart contract, where you have the function get the price, for instance, you have the function defined get the price, and the public view returns a data, and you use the feed of I don't know, Mesari or whatever. You should investigate on how they are providing you this data and from where. And of course, I told it before, of course, that their own Oracle could have kind of slippage to determine if the data are moving or not, if they are correlative or not, or if the data are. But the origin of the data is the first thing that we have to check. How this data is provided. It is not only a matter of an API that we link, that we point to our smart contract, Oracle, or whatever. We must determine how this data is being introduced, and if it is introduced through a cloud service, how this cloud service is being configured, and how this cloud service is checking that the data that they are using are the proper data and are the data that we need to use in the project. Because if we don't realize that, we will be having these problems that we are all time watching on our smart contracts. And when we have this function of get price, for instance, we have this situation. Some of the exploits that we can have on DeFi, for instance, when we have liquidations, some of these exploits are being produced because the get the price function is corrupted with data that it doesn't reflect the reality. So someone, intentionally or not, intentionally mainly, introduce this price wrong just to execute the liquidation. And then we all say that it was a problem of the code, that it was not secure, DeFi are not secure, tokens are not secure, cryptocurrencies are not secure, and it is not a problem of the code. It's a problem on how the data is being introduced in the code. It is a matter of how this data is being processed through a cloud service. And once the data go through this cloud service, then the data could be corrupt. And the data could be corrupt, and then the data could be going to the smart contract, and then I can alterate the data, or can alterate the logic of the code, and then we can have this kind of liquidation and all this kind of situation that we don't want. So to make it properly, in my opinion, we need to put more attention on this configuration of the cloud service, on how we are interacting with the cloud service. Of course, there is a soft logic to solve that, and it is not use data that is coming from a cloud service. But if we make this decision, maybe we cannot have access, or we cannot have access, or we cannot have data enough to manage our smart contract, and that could put us in a very big problem because if we don't have data, we don't have the input to execute the smart contract. So what I'm talking about now, and what I'm working about now, is on how this kind of audit of the cloud environment could be fixed through the Oracle to the smart contract. What I'm thinking about is how to use this script, or a script, to audit the cloud, how to introduce this script in the smart contract. When I say now the smart contract is the Oracle smart contract, in such a way that the smart contract will have the capability of audit or to trace the data. That could fix us with the problem of trust in the data provided by a cloud service. If you can make this, if you can introduce this script, you can put it on alert when data are not coming from a well-configured data cloud, from a non-trustable source, or from of a data cloud, or you can determine the different red flags that you can put in these situations. In the following months, I'm thinking on how to use the technologies that we have now accessible, on how we can improve this mechanism to audit the cloud services that are providing the data through to our Oracle. And maybe we can think about on how to use a kind of machine learning algorithm just to start to train this cloud audit function to determine how we can identify, determine, and identify the risk of the data provided. And maybe this could be, for me, of course, it's something interesting to do, but we must realize, and I ask you openly to make yourself the ones of you who are making code to think about that, to think about when we are writing the code, when we are using the Oracle, if we are checking or if we have any tool or if we have any function or how we are doing this audit, this checking on how this data is being provided to the smart contract, how the data is being provided to the oracles, because we know that how the oracles works. My previous colleagues were talking about that, but we must emphasize of how we are using these oracles and how these oracles can help us using this cybersecurity layer or these cybersecurity functions to optimize the data, the real data that we are using in our smart contract. Because trust, the truth or the truth of the data is subjective, no? I mean, no, we can say that, okay, if the data is provided by an institution, the data could be fine. And okay, we all know that we must not trust, we must verify. And if we verify that this data is provided through a cloud configuration, and if we can see, for instance, inside of the cloud architecture, who is the owner of the data, or how the data is being collected, we will realize that we are not using data that is real, in fact. For instance, when I was talking before about the smart contract of the weather, the process of capturing the data of the weather is being provided by a central institution. It is not provided by the millions of thermometers in the streets, in every place that could give us this info. It is provided by a central institution. And this central institution, you must verify if they are using good data. Why? Because most of these central institution or official institution or whatever, the Institute of the Health and whatever, they are not using real data. I mean, they are just putting their thermometers in a place and they took the temperature 3 times a day, and they are provided you this temperature 3 times a day, but they are not giving you the real data of the time, and it's a lack of optimized resources. So if we want to know, and this is a very simple example, but it can reflect very well what we are talking about. If we don't have the access to the real data in time, trustable, we will be introducing, again, in our Oracle, data that could alter, that could modify, that could pause our smart contract. So that is where why I'm quite focused on this kind of data. You can have also the chance or the alternative to use data provided by hardware, okay, and link this hardware directly to the smart contract Oracle. And maybe this is one point that could be very interesting in the following years. We need, and this is a big message, we need to develop own hardware to our projects. Because all these situations that I am talking to you about the problems of using data from cloud and the risk of the data used from cloud could be solved if we use hardware, if we use IoT devices, if we use our own devices, and our own devices could be made with a Raspberry Pi and a few sensors. This could be the opportunity to make a real decentralized network using these devices, physical devices, hardware devices, to capture, to generate the data that we need to our smart contracts. Because if we don't do that, and if we are using cloud services, we cannot have the 100% security of how this data, not only how this data are being collected, not only how this data is being processed, also how this data is being provided to you. And we all know which kind of business is in providing data. As much as you pay, as better info you have. And this is not aligned with our decentralization mindset. This is not allowed. So think, I will, just to finish, I would really want to make you think, or to invite you to think about this situation about how the data that we are collecting to our smart contract oracles that are using then in our smart contract projects, how we are collecting this data, and if this data is coming from cloud services, how the cloud service is configured, how the cloud services is collecting the data, how the cloud service is processing and storing the data, and how this data is being provided to you or to your project. So this is my reflections, my opinions that I wanted to share with you. I really appreciate the chance, the opportunity to talk with you. Thank you very much for the invitation from my colleagues from India. Thank you so much, all the people that have been listening to my ideas, or to listening on how these cloud vulnerabilities could affect to our smart contracts, and for instance, affecting to the smart contracts will affect to our lives, to our jobs, and to our passions. Thank you so much for your time. If you have any question, you can write it here in the message, or if you want to connect, you have in the main page my Twitter address, or my Twitter user, and of course through the organization you can contact. And well, I will be following the rest of the day as much as my connection could help me, and tomorrow I will be following the conference, and I'll try to be active and participate. Thank you so much for this chance, and thank you so much for this time.
Thank you, Pablo. Like, it was our honor to have you with us, and yes, it was a very nice aspect, we can say, because we often miss out the off-chain components, right? The cloud component, and we, like, most of the time we are talking about the smart contract vulnerabilities, right? All those vectors and all, and yes, we miss out the cloud itself, and which can lead out to some problematic vectors itself, right? Which you have pointed out, the implementation vectors, the operational vectors as well, right? If you're having a bad configuration, you will be getting a bad data from the oracles, right? So this was very wonderful to know about, and also this will help you can say auditors or all security enthusiasts to consider this aspect as well, that even though your smart contract is completely working fine, you still have the chance of being exploited, because the configuration on the server itself, on the cloud itself, is not giving you the consistent data, right?
Mm-hmm. That
So
is
that is one thing, right?
that is the main point. That is the main point. Thank you very much for this recap.
Right, right. And yes, thanks to you for showing us this side of this Web3 world as well. And yes, one thing I wanted to know, let's say, yes, we have a bad configuration onto the, like, let's say, cloud, right? So how we gonna tackle with that, right? Like, how you gonna tackle with that? Like, how you would be able, like, you would be finding that configuration, or let's say,
Mhm.
if it gets exploited, right, would be the next step, right, to solve that issue.
Yeah. Once that the bad data is introduced in the smart contract, we must find this pause function that
Hmm.
we talked before, because
Hmm.
most of the contracts includes this function. Most of the time it is not public. It is not public even in the GitHub, but they have this pause function. So if
Hmm.
we realize that for a mistake or whatever, bad data is coming to our smart contract, just try to identify the owner of the data, or
Hmm.
the owner of the code of the smart contract, and ask him to or her to identify the pause function, or try to identify by yourself the pause function and try to
Hmm.
activate it. Because you will be stopping, or you will be pausing the smart contract, so the exploit could not continue. And after that, you must do these forensics to
Hmm.
identify from which source came the data, and then if it comes through a cloud service, talk and speak with the cloud provider on
Hmm.
how this data was introduced, and then the forensics will continue through the origin.
Hmm. Yeah, thank you so much. Yeah, so these are the steps here that we have got from Pablo, and we all should follow that because this is a thing we don't usually consider, right? And Jean and Shubham has already given you a thanks for your talk. It was a wonderful talk, and yes, with that, I will like to say thank you for joining UnChained, for coming with us, and it was an honor for us as well. And hoping to see you soon, probably in another event and another collaboration we're gonna be doing. So yes, we will be meeting you soon, right?
Sure, sure,
And
sure. We will,
yeah,
we
I
will
just
be
wanted
talking.
to,
We will be
yeah,
talking soon.
yeah, I just wanted to tell the users that actually Pablo was getting like not getting good internet right before the talk, but somehow he managed. So cheers to him for his struggle. And yes, hoping to see you soon, Pablo. Yeah, bye bye. Have a nice
Bye
day.
bye. Thank you. Thank you so
Yeah.
much.